This video is about making esters. Making an ester from a carboxylic acid and an alcohol is one of the easiest reactions you can do in the organic laboratory. In fact, it's often the first lab you do when you take an introductory course. So how does it work? Well, you take a carboxylic acid, here we'll just use a simple acetic acid, and you put it in a solution of an alcohol. Here's just ethyl alcohol. Then what you do is you add a catalyst. What's the catalyst? The catalyst is a drop of a concentrated acid, like sulfuric acid. What's the sulfuric acid going to do? Well, of course, it's going to protonate the ethanol and make some oxonium ions. So let me set this up. We just protonated our ethanol. We got some oxonium ions. This is going to serve as our catalyst. So what's the first step? Well, the first step is protonating the acetic acid. Where do you protonate? Well, not the oxygen already has a hydrogen. The basic oxygen is the carbonyl. So you're going to protonate the carbonyl, and it'll just transfer a proton over, and you've got your protonated acid. So it looks a little weird. It's got two OH groups now, but of course they're delocalized between the two. And we've got some ethanol. Now, what's going to happen next? Well, we're going to attack the carbon of the carbonyl, and of course protonating it makes it more susceptible to nucleophilic attack. So we're going to have the oxygen of our ethanol come around and attack the carbon of the original carbonyl, and of course this will move the double bond out on. This will move the double bond out onto the oxygen. So here we go, and let's see what happens now. We're going to have our tetrahedral intermediate. So here's our tetrahedral intermediate. We still have the proton attached to the original alcohol, and what we want to do, of course, is we want to get rid of the OH, and we have to do that in terms of have it making a water molecule so it can leave. So what we need to do is to get the proton shifted from what was originally the alcohol to what was the original OH. So go like this, and do the transfer. So now we have the positive charge on one of the OHs, so it can leave as a water group. But again, just like when we did the hemiacetal-acetal sequence, we're not going to just kick out water and form a carbocation. We're going to push it out using the lone pair on the other OH group. So we're going to form a double bond, and that double bond formation will push out the water molecule. So that's not a very good arrow. We draw it a little bit better. There, it's a little bit better. And do that reaction. And so now, well, that didn't work. What did I do wrong? Oh, look at that, look at that, look at that. I put this arrow in the wrong place. That would be a terrible thing to do on the exam. Got to hit the bond, not the atom. So you see what it's, when I did the wrong thing, I got the wrong structure. So I'm going to erase this, hit that. I'll do it again. There, that's what I wanted. Now we have the protonated final ester, and all I need to do is to get rid of that proton on the carbonyl, and we got our final ester product. So here's an ester. Okay, now what about going backwards? Well, you could do that. Let's just say we took our ester. Okay, we had it for 5 minutes, and we decided we don't want it anymore, and we really want to go back to the acetic acid. So what would you do? Well, you just do the exact reverse. You take your ester, and you dissolve it or put it in some water. May not dissolve. Maybe it won't be soluble. This one probably is. It's pretty small. And you add your drop of sulfuric acid. So we add our drop of sulfuric acid. What's that going to give us? Well, it's going to give us hydronium ion. And we draw out some hydrogens. Okay, and put on our positive charge. So now we're just going to go through, and we're going to do exact reverse thing. What's the exact reverse thing? Well, we're going to take our carbonyl, and we're going to protonate it. So carbonyl attacked one of these protons, and we're going to get another water molecule back, of course, And here's we're just back to, well, where we're over there. But now, of course, what's going to attack, because we're now in water, we're not in alcohol, so the nucleophile is going to be a water molecule. Come attack the carbon, push the double bond back out, reform an OH. And so here we go. And now we just have to do the opposite. We want the alcohol to leave, so we have to transfer a proton to the oxygen here. Oops, let me redraw that a little bit. Oscar always has its own mind as to which proton to take. We go there. And we've now transferred that proton. We're ready to push out the alcohol, and what we do, of course, is the same trick as we did before. Is you take one of the lone pairs on one of the OH groups, doesn't matter which one, reform the double bond, kick out the alcohol now, and you're left with a protonated acid, I hope. Oops. So there's the protonated acid. Just get rid of the proton. And we should be done. Whoops, what did I do? Oh, geez, look at this. I'm terrible. Talk about ugly things. What did I just do? I made a terrible mistake. Horrible mistake. Again, that arrow was supposed to be going to the atom. I'm not. Why didn't you tell me I was doing it the wrong way? There we go. Now I push the button. Ah, there we go. Perfect. So here's our acetic acid back. So let's go through the sequence again. Acetic acid in protonated ethanol. We protonate the acetic acid. We attack with the alcohol. We get our tetrahedral intermediate. We do a proton transfer. We get back now a protonated ester. Lose the proton. We've got our ester. If we want to go backwards, we just have to do the same thing. In water, put it in water. Protonate the carbonyl. Attack with the water. Get our 4-coordinate intermediate. Transfer the proton. Get our protonated acetic acid, and lose the proton, and we're done. So that's the sequence, and it works forward or backwards. Very nice.